In Algebra 2, section 2.6, we're going to be dealing with special functions. Now the chapter actually has several special functions, but we're going to be focusing on two, and that's piecewise functions and absolute value functions. The issue is that instead of me trying to explain what each one is, I'm going to go ahead and explain it while we're doing example problems. So actually we're going straight into example problems. But don't forget to go ahead and still do the vocabulary and also write this down. So the first one, we're dealing with a piecewise function. And basically what a piecewise function is, it's multiple graphs put into one, but they each have their own boundaries. So what that means is the equation for this, for x, so this is x is less than 3 and x is greater than 3. So anything that is less than 3, so let's find 3 on x. 1, 2, 3. So write and put a different color. So 3 is our marker. What that means is that anything on this side, which is less than 3, my equation is f of x, which is the same thing as saying y equals x minus 1. Okay? And then what it's saying here is that anything that's bigger than 3, it's saying that the equation is y equals 3. And this is called a constant function. So what that means is anything y equals means that it's going to go straight left and right. So that means that I'm going to find 3 on y, okay, and starting here, and because the line is not on here, I'm going to put an open circle. Because the line is not here, I'm just going to go straight this way. So again, essentially what I'm doing is I'm graphing two different equations that you already know how to graph, but I'm sharing the graph. And 3 is the boundary. So here on 3, this includes 3 on top, so I'm going to put a closed circle. This one is an open circle because it doesn't include 3. So on this one right here, it's telling me that the equation is x minus 1. So we're going to go negative 1, which is right here, and we're going to go, what's the slope? The slope is 1 over 1. So what that tells me is I'm going to start, this is the negative 1 down here, because it's y-intercept, this is the y-intercept, and I'm going to go up 1 over 1, up 1 over 1, up 1 over 1, and so on and so forth. And because this has a line under it, it's closed circle, and I'm going to go down this way. Now essentially this is going to be a little bit confusing, but basically it's like taking two different graphs and merging them together. And this is going to be not included because there's no or equal to. This one has or equal to, and that's why it's closed circle, so that's the difference. And this is y equals 3 because f of x is the same thing as y. So y equals, my apologies, it's y equals negative 1. Some of you guys probably already caught that. I could technically re-record this, but it'd just be better if we did this. Okay. So it's actually y equals negative 1. My apologies. So I'm going to find negative 1 here, and it's going to be, again, open or closed circle. It's going to be open circle. I go this way. So anything y equals is called a constant function, which is in your vocabulary. And basically I find it on y, and I go here. So if I wanted to graph this just in general, I would have started here and done this whole thing. But because it's only when it's greater than 3, then I need to put it greater than 3. This one is going to be less than 3, so this line, y equals x minus 1, only applies to that side. So go ahead and try that. This is page 99, number 8. So on page 99, number 8, you're going to try piecewise function and see how that goes. If not, we'll go over it in class. The next one is an absolute value. This one you've seen written as an equation when we dealt with solving an absolute value in chapter 1, but here we're actually graphing it. Now when we're graphing the absolute value, what we're going to be doing is just this chart. Now remember how we did the table? And what were the equations that we tried the table? We started with negative 2, negative 1, 0, 1, and 2. Again, these numbers are the ones I chose, and we're just going to plug it in. Now, the thing is this absolute value only applies to the x. It does not apply to the minus 3. So first I'm going to do an absolute value to whatever I put in for x, and then I subtract 3. This is different than if the absolute value was over the whole thing. Then I would do the whole thing and then apply absolute value. And absolute value, again, means that whatever's in it is always what? Positive. So first I'm going to do negative 2 absolute value minus 3. So this would be 2 minus 3, which gives me negative 1. The next one is negative 1 minus 3. This would be 1 minus 3, which means it is negative 2. This is the absolute value of 0, still 0 minus 3, so I would have negative 3. And this is 1. The absolute value of 1 minus 3 is still 1 minus 3, which is negative 1. And finally, the absolute value of 2 is still 2. So it's 2 minus 3, which would be, this is negative 2 and this is negative 1. So once I have that, I'm going to go ahead and graph this. So we have negative 2, negative 1. So I'm going to go back 2, down 1. That's my first one. The first one is back 1, down 2. Second one. The next one is 0, down 3. Okay. The next one is 1, down 2. And then the last one is 2, down 1. So my absolute value is a V shape. An absolute value is always this shape. Oh. So you should end up, you know how a line is always a line? Well, absolute value will always be a V shape. It could be moved anywhere, but you should have a V shape. And if not, then you should fill this in. There's no questions on that. There's page 99, number 6. Go ahead and try it. Don't forget the graph. And please remember that this absolute value only applies to the x here. It's different if this equation was f of x equals x minus 3. Those are two different equations. Because in this one I'm going to take x, subtract by 3, and then do an absolute value. But this one I'm going to do the absolute value of the x first and then subtract by 3. So try page 99, number 6, and I will see you tomorrow.